All right, hi. I'm Dr. Ben Newman. I'm a coronavirus researcher here at Texas A&M, but I'm not doing this officially. This is just me, and opinions are all my own. Yeah. Let's see. Next question is from Holly. How's it going? All right. Let's see. Hi, Dr. Ben. Hope you're all doing well in CSTX. Yeah, absolutely. College Station is pretty cool. Yeah, I like it. My questions, since the beginning, have tended to focus on, oh my goodness, neurological and long term effects of the virus. I like those questions. They are not being asked enough, I think, by the public at large. But I think there are a couple of people that have right from the beginning been saying, whoa, watch out for that. And so, yeah, that's cool. That's cool that you're one of these. All right. Both my parents have suffered with dementia. Ugh, yeah, sorry to hear that. And I was a hospital based speech pathologist, neat, who worked with people who were stroke and brain injury survivors. Oh my goodness, yeah, your experience with post COVID syndrome would be very interesting, I think. I'd love to hear about it at some point. Let's see. So I'm kind of all about protect your brain and your cardiovascular system, basically your health in general, but, sure. You know what? Yeah, I'm with you. 100% with you. I saw this paper and wondered what you thought about it. And there's a link to the paper down there. And there have been discussions of of neurological damage from COVID-19. Yeah. And so I had opened up the paper, and the paper is about it's a really neat study in that they took people who had already had brain scans. And so you had kind of a starting point. And then of these people, they selected about half who subsequently went on and ended up with COVID, unfortunately, and half who never did. And they then compared the brains before and after COVID. And so they had people who had it and didn't have it. And they were looking, okay, is there a difference? Because there are changes you get with age, there are changes you get with things like dementia, various traumatic injuries, yeah, definitely cause changes in there as far as I know. Not a brain scientist, much more of a virus scientist, and really only a few. So this is my childlike reading of this thing. So the paper actually uses kind of crude measurements for the brain. They are basically trying to weigh and measure the brain without actually taking it out of your head. That's the imaging, and they're looking at how big it is and how meaty and delicious your brain is. And what they find is that surprisingly, there are pretty big changes. Actual loss of gray matter. It's not like the brain shrinks to a tiny little nut, but you have spots all over the brain where there is loss of gray matter. One of those spots they point out is the hippocampus, and I think the amygdala was another one, and I forget what the other one was. So, reading around, which I had to do a little bit of homework to even try to answer this actually really good specialist question. I looked, and there is a body of literature about the effects of inflammation. So what the rest of the study is saying is this direct virus damage, or the rest of the question is saying, sorry, is this direct virus damage, or is this like secondary damage? Like the virus damages something and then your immune system goes nuts, which we know happens in COVID. And then that process, which is called inflammation or hyperinflammation, yeah, or sometimes an exuberant inflammatory response, that's another name for it, will then just damage everything that's connected with the blood system. And there's lots of blood going through your brain because your brain needs oxygen. That's how you think, yeah, which is fine. And so in lab animals and in people who have had bipolar disorder or obesity or who are getting older. In all those cases, you have, or with the lab animals, you can actually induce inflammation, sort of chronic inflammation, which is kind of what having COVID is. If you have COVID for a long time, you are getting a long-term immune response, which, like it or not, all that blood is going to go through the brain, and anything that the immune system puts into the blood is going to affect the brain at least as much as the rest of the body. And your brain, your brain is kind of special. And, whereas a muscle can repair some cells and still work pretty much like before, you start messing with neurons, you potentially lose connections, and some things that used to work well no longer work very well. That's again my childlike understanding of this. So in those other studies, there is actually a pretty good body of literature showing that long-term inflammation causes loss of gray matter. And loss of gray matter, this is like holding a measuring tape up to the brain saying, yep, smaller, something's not there anymore. This is the, I think, crudest possible way to look at what it's actually doing to the brain. So if you have chunks of your brain that are no longer there, you can be pretty sure something is different post-COVID. But you can have brains that would still look the same, and they can be damaged in a way that you can't see, but which still directly affects how the brain works, how you do on things. And we do have information. People do not test as well before COVID and after in studies where that's been done. There are neurological deficits, like brain problems, where it just does not work as well after COVID. You've probably heard of COVID brain. That appears to be a thing, and we still aren't sure exactly how long it goes on for after COVID, or whether it ever gets back all the way to normal. There are people that are looking at this, but they're still kind of building up enough evidence to the point where I think it's believable. So, I'm waiting to see more there. So, it's an interesting study, and I think the other point from the study is that they found a big difference between people who had COVID and did not have COVID. They only had a real small group. I think it was only 15 people who, out of 384, if I remember right, who were in the hospital with COVID. And so they didn't have a big enough sample to show that people who were hospitalized with COVID had worse brain damage than people who just had regular COVID. But you could detect the COVID in everybody. And it did look like the trend was that the people who were in hospital were maybe a little bit more severe loss of gray matter, but they did not have enough data to actually be able to say that beyond a reasonable doubt with statistical certainty anyway. So that one's a conclusion we can't really latch onto yet, but it would make sense. More severe disease. The disease comes from activation, or rather inappropriate activation, of the immune system in large part. And I don't see how all those what they call pro-inflammatory modulators and things running through the brain couldn't cause a lot of damage. I don't see why it wouldn't. So there you go. Direct evidence of brain atrophy associated with COVID in people who have recovered and not in people who didn't. Just another reason to, as the questioner, who's that? Holly. Yeah, there you go, Holly. Holly says, my next favorite motto to protect your brain is vaccines are better than natural infection. And duh, right? Reading a wanted poster and recognizing a felon is much better than getting naturally mugged. Reading a warning sign that says don't stand under the cliff with the falling boulders is a lot better than getting naturally smashed flat by a boulder. Putting the word natural in front of it seems like it should make it better, but it's it's really dumb. Naturally shooting yourself in the foot with a natural gun is much stupider than not doing that. So definitely vaccine all the way. It's just a much gentler, more thorough way to vaccinate, and the consequences are virtually nil compared to the extremely bad consequences of actual infection, which involves brain damage and hyper blood clotting in just about everybody that gets infected. So stay off COVID, kids. Stay in school. All right, thanks a lot. This is Ask Dr. Ben.